All right. So simple one again. Finite or infinite impulse response? Finite. So this guy has a name. Yn equals to? Yn equals to? You want to say xn convolved with hn, the convolution. Well, hn is the impulse response. Since xn is the impulse, you will reduce to h of n. Okay? You go and prove. Something convolved with an impulse is a something. You see? Because here later on you see x of n, sorry, delta of n convolved with h of n is reduced to, yeah? Correct? Yeah? Now, so we want to check. Is it absolutely summable? So it is nothing but 1 square, no, sorry, 1 plus 2, and the system is absolutely summable. So it's very simple, and therefore we say it's stable. Why do we say that? Okay, so let's try again. So we know that y of n equals to h of n convolved with x of n. Any problem so far? Equals to summation xk. Can you help me? Xk what? Next one? H n minus k, correct? Yeah? So this is x convolved with h. Okay? Convolution is commutative, means I can switch the order around. Means summation hk what? X n minus k. Okay? Now, I'm going to do this. If I put the absolute here, what will happen? I must absolute here. Agree? So this guy is sometimes positive value, sometimes negative value, right? So now I'm going to write another equation that looks like this. hk absolute x of n minus k absolute. Now I'm going to ask you, is this equation larger or this equation is larger? Who will produce a larger value? Sir? This equation will be larger than this, or this will be larger than this? Absolutely. Of course this, friend. Because it's positive number multiplied by positive number, always a positive number. Keep on positive, positive number is always positive number. Here, sometimes it's positive number multiplied by negative number, so I can add positive, negative. So it is always greater, equal, okay? So right hand side is always greater than left hand side, okay? Now, I want to find whether the system is stable or not. So the stability criteria is called BIVO. The BI stand for bounded who? Input. Who's the input? X. Okay? So I now set my largest x value, my height, to Bx. Okay? Okay? Now, summation h of k Bx. Who's larger, this or this? Bx is the largest value, right? So the largest value times h is always, of course, sometimes smaller, right? So of course this guy is, yes? Yeah? Okay. Let me ask you, my left hand side is what? Y of n. I'm interested in my y of n to be bounded. I've already tell you my input is bounded. Okay? How will be my output be bounded? How? If my input, I've already given you, yeah, the biggest. How would y not go to infinity? What is the condition? Already here, come guys, the impulse response must be absolutely summable. See? Not bounded, absolutely summable, can? If this guy, I'm going to bring him out, correct? Yeah? Then what? Only this condition is interesting. Can you see now? I keep on throwing things away until the only thing that is really important sits here. My output is the largest I can ever find. As long as my impulse response is absolutely summable, right? Then my output will be absolutely summable. Sorry, my output will be not infinity. Can? Because as long as I keep on adding, doesn't go to infinity, doesn't go into infinity, multiply by something, doesn't go to infinity. Correct? Because this guy is not infinity, this guy is not infinity, therefore my left hand side, which is absolute value of yn, is not infinity. Therefore my output is bounded. Can? So there, only 4 equations there to see. Okay. So the last answer is one. It is a sufficient condition. Yeah. If we check is the absolutely summable, then the system is stable. If I send x towards LTI system, y is equals to, what's the equation I'll write? Y equals to, this is LTI, y equals to something, something h. X, what? H. X convolve with h, okay? And then you write the convolution equation. If now I send h into a system, and this x looks like this guy, h convolve with x, I'll still get y. And convolution, x convolve with h, and h convolve with x, convolve with h, and h convolve with x will produce the same y. Just like 2 times 3 is the same as 3 times 2. It's commutative. What about this guy? I send a system x firing into h1. h1 firing into h2. That means this guy is, what's this value? So, x? Yes, x convolve with h1. Then here, x convolve with h1 is now convolve with h2. It's the same as x h1 convolve with h2. Can you see? So this one, this property is called the associative property. Associative means 1 plus 2 plus 3. Whether you do 1 plus 2 first or 2 plus 3 first, doesn't matter. Okay? The brackets, doesn't matter, you can shift it around. So it's commutative and associative. Distributive. Let's try the most simple one. Ma'am, I'm going to fire an impulse, pump. What do I see? Correct, but I'm only sending an impulse, so it's pump. X is delta n. So H1. Here, H2. So here, yes. So H1 plus H2. Okay? And now, you see this. Okay? So if I draw very complicated blocks for you, then you can reduce it to simpler ones.